Hi everyone, so I am Naheed. Today I'll be showcasing a project which we have made for the fifth semester of our CS course. And my team member MD.Ashrafuzzaman helped me while making this project. So what's this project is about? So it's the project name is Titan Engine. Actually, it's an online compiler. So uh, just understand that we'll be given some scripts, and those scripts will be run in a virtual machine. Like here you could see that a PC in a sandbox environment, and the output will be sent to the browser. In this way, a person can easily run different types of scripts of different languages in the browser. So let's see the demo of the project now. Okay, and we have a XAMPP server running in the background, and I'll not be showing that localhost, and it's running on port 3000, but the main API is running on this another server. So here you could see that it's loading. I just don't know why it's taking such long. Yeah, so here you could see that build a scalable coding platform with Titan API. So it's an online compiler, Titan Engine. So there are some supported languages, that is C, C++, Python, Java, and JavaScript. And this is the desktop UI. This is the home page actually, and we have also optimized it for mobile use cases. I'll be showing the demo, and later on I'll be discussing briefly how it works, what's the architecture behind it. So you can see that the UI. Okay, now enough for the UI. There are many UI elements like products page, API, and the support page and the pricing. So there are like many types of pricing. Now let's see. We don't have to sign up for this demo case since I have already created an account. But if you want to create an account, you can click on the get started button. Now let's sign up. Just log in, and yeah, remember me, and then I'll just click on the sign in button. So then we'll be on the editor page. So here you can see this is an editor, and in this editor there are like three sections. The first section is the code section. Here is the standard input section, and here is the output section. So any type of input data will be written here, and the code will be written here, and the output will be shown here. So let's write something. Let's say print hello world. Print hello world. So actually I'm writing in Python, so I'll select the Python language and I'll just hit run. So here you could see that it ran and it shows that successful, and we are seeing hello world as the output. And there are some other buttons too. Since we have been logged in, so we could also load some other files. These are the files I have created before showing this demo. So these are demo files like test1.java. So this is a demo of a Java app, JavaScript. So here you can see that we could also run Java programs very easily. So this Java programs runs a series of 10 of all Fibonacci numbers. And let's run another program. Let's say leap year, a C++ program. So it tells whether the 222 the current year is leap year or not. And if we run the program, if we run the program C++, and if we just run it, and it will show that it's not a leap year. Now you may be thinking, what if we make some kind of mistakes like compile time error or runtime error? Let's say we're making a compile time error by not including this semicolon. So if we run this program, and it will just the compiler will say that on line 17 to 18 there is a semicolon missing. it works the same way if you run this program, if you run this script on your own PC. It's just the same, but we are running this on a dedicated server on Microsoft Azure, and it's running in a sandbox environment. So you can't just like poke bomb on do any sort of malicious things on that case. Now you could also make some changes, like you could also make some changes. Now let's load another program like this hello.py, and let's say if you wanna make some changes, you would not write hello, let's write okay, and you wanna save this file, so you will just click on the save file, and it has been saved. See, it has been saved. And if you want to delete any file, just click on the cross button and the file would be deleted. It's so easy. So now I will be showing you the technical details behind it, how this thing works. But some more technical things before going on that. This UI, this whole UI is made using pure HTML, CSS, and JavaScript. We haven't used any library of framework because our criteria was not to use any of those things. So for this reason, it was a little bit harder for us for achieving our goal, but we have managed to do it. So let's inspect now. Let's go on to the mobile mode. So in the mobile mode, you can see that here you can see like 3 tabs: first tab, second tab, and the third tab. And what happens is that in the mobile mode, the tab is stacked on top of each other. Here you can see that the tabs are stacked on top of each other in mobile mode, and it's a very intuitive way to run this app on the mobile devices you have. So let's run something, and okay, so it's saying that something is wrong. The reason behind it is that we have used the wrong language. Now one more thing to notice is that when you run the run button, you could see that it's successful. But let's say let's see a program, let's see a CPP program where it takes a little bit more time. So let's write a CPP program. So this in this CPP program, this header includes all the header files. For this reason, it takes a little bit more time for compilation. So let's write COUT hello. Now if I just click let's clear the console, and if I just hit enter, here you could see that it's processing and then it's successful. So one thing to notice is that let's imagine a scenario where there are multiple users and they are trying to get this script run. Now if there are multiple users, we have to handle each and every users in such a way that we have to also respond to them, like saying that your script may take a little bit more time, just wait. So this can be done by using a queue. And while discussing the architecture, I'll be discussing this topic also. And here you can see that we're getting the response recursively. I have written a recursive program for getting the response as fast as possible without stopping for like 2 seconds or 1 second. Now let's clear. Okay, so one more thing to showcase is, okay, so this is the PHP myadmin. So here you can see that I have just created just one user. So this is the username, and we're saving the file. You can see that we're saving the file, and we're linking up with our user. We are linking it up with our user using the foreign key. And we want to see execution engine, and if you want to see the like, yeah, so how it's linked up now, you can see very easily. So here you can see that the file data, the ID is linked up with the primary key of the user ID. Okay, now let's see the architecture. So this is the peak of the architecture. You can see that there are actually two apps. One is the client side, that is the website, and the other is the API. And the API is being hosted on Microsoft Azure platform. So what happens is that, let's say, first of all, we need to sign in and sign up. And this sign in and sign up uses these routes, and the data is stored in the MySQL database. Now, in the editor.ejs, that is the editor page, we have shown. In the editor page, whenever we write some code and we hit the run button, the code will be sent as a post request to the Nodejs Express server on the cloud using the fetch API. So the code is sent through this pipeline, and here the Node.js Express server will receive the post request. Now, since there can be more than one user and they are requesting something concurrently, so these type of requests should be handled, and each and every request should be handled in such a way that no request should be omitted or be deleted. So for this reason, we're using a RabbitMQ. This is a task queue server. So what this task queue server does is that it's practically a queue, and whenever a request is being made, it will process request one by one, and after the request has been processed, it will acknowledge that request and say that the request has been processed. And here you could see that we're using like 3 Docker containers. You could use more than one Docker containers, and what this Docker container will do is that it will run like C, C++, Java, or Python 3 codes in a black box environment. And each of these containers are given a limited space, like these containers are given like 250 MB of spaces. For this reason, those containers for these reasons, if someone fork bombs or like writes some malicious code that eats up the memory, nothing will happen to our whole API, because it's inside a Docker container. Because if a Docker container fails, and it will restart again. So it's very efficient in that case. Now, when any type of data, let's say there's a CPP program to write a hello world, so the post request comes in the RabbitMQ task queue, and the RabbitMQ sends to one of the Docker containers. So how will a user know if the post request he has sent is run or not, is being run or not? When the post request is being sent to the RabbitMQ server, the RabbitMQ gives the user a unique ID and says that here you take my key and ask me each and every time if the data has been processed or not. And when the Docker container processes the data, it will write the data in the Redis cache server, and you can get the data from the Redis cache server using the key that has been given by the RabbitMQ server to the user. And the user will ask each time if his or her data has been processed or not. And if it's in the processing stage, that means it's in the queue, then it will say that it's in the processing stage. Now then, if it's the process has been finished, which means the data is in the cache server, that is Redis server, then it will say the data is in the cache server, and it will return the response back to the user. Now one more thing to notice is that wait now one more thing to notice is that here in the editor section, you could see that since we haven't used any sort of a library for the UI, everything has to be written in pure HTML, CSS, and JavaScript. And it's a very, very hard work to do if you are writing everything in HTML, CSS, and JavaScript. So here you could see that these things are resizable, and the scripts are, everything is written in pure JS. Now one more thing to notice is that here we have some buttons, that is load and save buttons. So if we click on the load button, here you can see that a model has been opened. Now since it's a client-side language, express.js is the client-side language, so we can't reload this page, and we have to get all the data from the server. But how can we achieve that? Now let's see the picture. So let's see the picture and you could understand it. Let's say we wanna get the name of the files that has been saved, but how will we get the file without reloading the page? Now for this reason we're using a fetch API. So it's an internal API that has been built for the JS. So using the fetch API, we'll call a route. So the route name is like get file, save as file, save file, and delete file. And these routes will call the database to get the data. And in response, we'll get the data through the fetch API to the editor page. In this way, this app works. And we have also made some user profiles, user update profiles, and other tasks too. Let's go to the browser. So here you could see that we have a user profile section. You could just edit data here. Let's say go update. Yeah, so profile has been updated. And if we see the user data, yeah, so the profile has been updated. So and what's the pricing section? Now let's talk about some pricing sections. So many there is a big market for this type of APIs. The reason behind it is that big tech companies such as like AWS, CodeChef, so HackerRank, HackerEarth, they use this type of services. What they do is that they need a type of services where they wanna run different type of scripts, and they don't want to handle those types of scripts for their use cases. So they just build an app. So they just build an UI for their homepage and vice versa and other things, and they just give this task to other vendors for making this happen. So we have some like pricing sections. Here you could see that if you're using this for just for learning purposes, so it's $0 per month. And if you are using like for organization, you could it's like $15 per month, and you could send like 500 requests, and you will be given 3 worker nodes for code execution, and you will be given like technical supports. And if you need something more robust and something much more big, then you have to pay like $40 per month, and custom number of nodes and custom number of requests, custom number of CPU cores you will be given, and other facilities you'll be given. So that's it for today. I hope you liked this project, and throughout this project we have learned a lot about how API works, how the computer works, how the processes works, and how to handle such type of things. And we have learned a lot, and I hope these types of project will enable you to build some more unique projects in the future. That's it for today. I hope you'll like it, and bye.